Linear inequalities. Solutions to a linear inequality with two variables, that's, when you have your x, y, can be represented in the coordinate plane as a set of all points on one side of that boundary. And what we're going to talk about is, real world situations are better modeled by an inequality than the equation, because when we have an equation, it models a situation where the conditions must be met exactly, while an inequality models situations in a range of values, and it's sufficient to meet a condition and it doesn't have to be exact. So we will often write linear inequalities into slope-intercept form to where we are able to easily graph them, and shaded areas of the solution. So whatever the inequality, whatever side of the barrier boundary line is a true statement for our inequality, is considered the solution of the inequality. And in looking at the boundary, so if I have a very simple coordinate plane, and I were to draw in a inequality, and we'll call that y is greater than x, greater than or equal to x, we would shade everything on this side of the boundary line, and then everything that appeared on that half of the plane would be a solution. And we will do more with this, but just as an idea that instead of just being a line, it's going to be an entire region that represents the solution. As we look at identifying solutions to a linear inequality, that is going to be those regions in which, or those points and regions which make the inequality a true statement. So if we were to try to find is the ordered pair going to be a solution to the equation? Well, to the inequality. Our inequality is y is greater than x minus 3. So what we're going to do is we're simply going to replace our value of x and y into our inequality and see if it's a true statement. So in replacing y, we would replace it with 2, and we would replace our x with 1, and then complete the inequality. So we have 2 is greater than 1 minus 3, or 2 is greater than negative 2. So that is a true statement. Therefore, that is a solution to our inequality. Now, if we look at this next ordered pair, we are looking at negative 3 and negative 7. So we have y is greater than x minus 3. So we replace our y with negative 7, place our x with negative 3, and of course continue our inequality. So that gives us, simplifying, gives us negative 7 is greater than negative 3 minus 3, which is negative 6. And that is not true. That is not a true statement. Remember, when we're talking about the negative values, the farther I get away from 0, the smaller the number is. So as we go down, not a very good number line, but this would be negative 7 right there. Negative 7 is farther away from 0 than negative 6, so that's not true. So that is not a solution to my inequality, not a true statement. And of course, if we do the same with this last example, where is 3, 6 a solution to y is less than or equal to 2/3 x plus 4? Well, we just go ahead and substitute, in for y and x. And then we end up with 6 is less than or equal to 2 plus 4, or 6 is less than or equal to 6, and that is a true statement. Therefore, it is a solution. So as we're just identifying, how do you find if an ordered pair is a solution to a linear inequality, and you just do the substitution. Now, graphing an inequality with two variables. Well, we're going to graph these very similar to the way that we would graph a line in slope-intercept form. Some things that we're going to have to remember, we're going to have to, or think about, but I'm going to go ahead and create my coordinate planes real quick. Okay, and now when we're graphing these, of course, we're going to graph them like a like a line, like something from slope-intercept form, but we have to remember that since it's an inequality, if you recall some of the things that we knew about inequalities when we were graphing an inequality along a number line, if we had an open circle, that meant that it was not included. That also meant that we had possibly a less than or greater than symbol. And then, of course, when we had a closed circle, that would have been less than or equal to or greater than or equal to because it was included. And what we need to associate here is when we're doing our linear inequality and we are drawing our line, the connection to be made here is before, if I had less than on the number line, that was considered an open circle, and that then would also be dashed when we go to graph a line. The same falls for greater, or the same goes for greater than, will be, it was a open circle, and it will also be graphed with a dashed line, and because that means whatever's on the line is not included. That's what that dash means. Whereas the other is when we have less than or equal to, we had a closed circle, and that will be graphed with a solid line. Just like an equation, whatever falls on that line is also included in its solution. And then we had greater than or equal to, again, colored in circle, a solid circle because it was included, and it will get a solid line on the graph. So just remembering those four things and trying to connect the dashed line to the open circle, and we can go from there. So looking at this, how to graph this, some students still struggle with y equals mx plus b. Now, if y equals mx plus b, we know that m is going to be my slope, and b is going to be my y-intercept. So when I go to graph these, I'm going to graph them in that same instance or in that same circumstance or situation. So in this equation or this inequality, y is greater than x minus 2. So I should be able to look at that and say, okay, my slope is the coefficient of x, which is 1, and my y-intercept is going to be negative 2. So I'm going to start there and worry about graphing it, but I did forget to label my graph here. Goodness. Go ahead and make sure I put in my scale, otherwise it just wouldn't be right. Okay, there's my scale. So to graph this again, I'm going to go to my y-intercept, which is negative 2, which is the ordered pair 0, negative 2. So I start right here, and I'm going to go, my slope is 1, which could be 1 over 1, 1 over 1, or it could be negative 1 over negative 1. And so if I start there and I go up 1 over 1, here's going to be my next point, up 1 over 1, next point. Coming back over here, I can go down 1, back 1. And remember, it's going to have a dashed line here because this is going to be greater than, not greater than or equal to. So when I go to graph, I'm going to use a dashed line, up 1 over 1, there's my down 1, back 1, which would have been these points right here in case you have forgotten. And then now, which way to shade? That is one of the problems here, that since it's y is greater than, well, if I look here, when I start off at this point right here, negative 2, which way is greater than negative 2? Well, negative 1 would be greater. So greater means I'm going to shade upward. So when I go to shade upward, it's going to be everything above my line. Okay? Everything above the line because we're going to shade upward. And we're also going to check it. We can check it by plugging in some points, just like we did on the last part of the lesson. So if we go to check this, and everything above my boundary line should be a solution, which my boundary line splits it into half planes. If I pick any point, I can pick 0, 0. That's in my shaded in area. Plug it back into my original equation and see what happens. So if I take 0, 0, and I have y is greater than x minus 2, replace x and y was 0. So 0 is greater than 0 minus 2, or 0 is greater than negative 2, and that is true. That's true, so that is a solution. Now we can turn around and take a point out of the non-solution area and see what happens. So if I take 3, negative 3, so I'm going to have negative 3 is greater than 3 minus 3, and then negative 3 is greater than, sorry, I wrote that wrong, negative 3 minus 2, so negative 3 is greater than 1, and that is not a true statement. That is false, so that is not a solution set. So yes, so my solution definitely falls above my line. And if we need to check the dashed line, for example, well, we have dashed, and that means that it's not included in my solution set. Well, I can pick any one of these points right here, and I can say that 0 or 2, 0 is going to be a solution or not a solution. 2, 0 is on my dashed line, and that is going to give me y is greater than x minus 2, or 0 is greater than 2 minus 2, 0 is greater than 0. 0 is not greater than 0, so it's not a true statement. So therefore, looking at some of the caveats and some of the intricacies of linear inequalities. All right, so we can go ahead and graph this next one. And looking at this next inequality, my slope is going to be 1/2, and then my y-intercept is going to be 1. So I'm going to start graphing at 1. Right there. And of course my scale is very important. So I started graphing at y is equal to 1, right? 0, 1. And then my slope is going to be 1/2. So I'm going to go up 1/2, or I'm going to go up 1 and right 2. That's positive 1, positive 2. I could also graph negative 1, negative 2, which would just bring me down, down 1, back 2, down 1, back 2, or I'm going to go up 1, right 2. And in doing so, let's see, we'll pick blue, and if I go up 1, over 2, up 1, over 2, or I go down 1, back 2, down 1, back 2. And as I go to connect that, since it's less than or equal to, I'm going to use a solid line. Okay, because that means it's included. Any points that appear on the line are included. And then when I go to do my shading, since it is y is less than, I'm going to go ahead and shade the numbers of y that are less than 1, which is going to be everything going downward. So there you go. We have this shaded region is going to be our solution set to that inequality. And again, you can plug a number in there. Origin is often very easy to use. So using the origin, I could say that 0, 0, 0. So we have y is less than or equal to 1/2 x plus 1. So substituting in 0, 0 times 0 plus 1, and that gives me 0 is less than or equal to 1. And yes, that is a true statement. True. So there, my solutions do fall within that blue shaded area. And graphing linear inequalities is a little bit challenging. But again, once you get used to putting it on the graph and creating graphs, it's not too much to do. So a quick recap or a quick look at it, linear inequalities has is coordinate on the plane. We have a solution of an inequality which would fall somewhere in the shaded region, and that shaded region would be half the plane. This boundary line, this equation or this inequality boundary line is what splits the coordinate plane in half. This half of the coordinate plane is a solution. This half of the coordinate plane is not a solution. And there you have it, linear inequalities. Graphing some simple graphs here. Go ahead and I'm going to plug in my graphs real quick. Okay, so when we go to graph these lines, look at them and let's see here. I have x is less than negative 5. Less than. open circle. It's not included, so we will use a dashed line here. So I know it, x is -5. Oh goodness, that's not a very good graph at all. Let me fix that. Okay, so as we graph x is less than -5, so I just go to x is -5, which would be 1, 2, 3, 4, 5. X is -5 here, and it's going to be a vertical line, and that is going to be dashed because it is not included. So we have a dashed vertical line. And then it's going to be less than, so we're going to shade less than, which is, goodness, which is this direction right here, less than, the numbers that are going to be smaller than -5. Now, if we continue on, let's go ahead and look here at y is less than or equal to 2. So here we're going to be using a solid line because it is also equal to, and we have right here, that is going to be y is less than or equal to 2. So we will shade less than, which is going to be downward, because the numbers of y are down, are going to be less than what was up there. Okay, and looking at this next one, x is greater than -1. Okay, so -1 here, it's going to be dashed because it is greater than, and it is not equal to. It is greater than. So we have at x is -1, which the line I just put in there was y is -1. So let's go ahead and fix that. X is -1 is right here. Again, a vertical line. And we're going to shade that for the values that are, I said it again, I said less than, for the values x is greater than -1, so the greater numbers, the greater numbers that we have for x occur to the right. So here you go, we're going to shade to the right because those are the numbers that are greater than -1. And then last but not least, we have y is going to be greater than or equal to 2. So we have a solid line because it is also equal to. And we go ahead and graph that, and we know that if it's greater than, we're going to be shading upward. So I'm going to shade everything that is above that line, and the solutions are also included all along the line because the solid is an inclusion. So there you go. That's what those should be graphed like. Now, as we go into talking about writing a graph of an inequality, well, you know, for a party, you can spend no more than $12 on nuts. Peanuts cost $2 a pound. Cashews cost $4 a pound. And what are some possible combinations? Well, we learned some combination problems with linear equations. And what we want to do is we're going to write a inequality, and we can use our standard form. And so we know that if I have no more than $12 to spend, so that means no more than 12, so it must be less than or equal to $12. And I know that my peanuts are going to cost $2 a pound, and my cashews are going to cost $4 a pound. So if we call my peanuts X and my cashews Y, then this would be, peanuts would be $2 per pound, and then cashews would be $4 per pound. So we have 2x plus 2y must be less than or equal to, that is 4y, must be less than or equal to $12. And of course, these are dollars. So we could find our limits. Okay, and finding our limits would be finding our intercepts. So, for example, what would happen if we bought no cashews and all peanuts? Well, if y was equal to 0, that would be the same thing as our x-intercept, correct? So if we have 2x plus 4, 0 is less than or equal to 12, then we know that 2x is less than or equal to 12, dividing by my coefficient, and x is going to be less than or equal to 6. So there we go. We know that if we buy no cashews, we can buy 6 pounds of peanuts. That's what that is. 6 pounds of peanuts. So if we go ahead and graph that, 0, 6 would put me right about there. 0 cashews and 6 peanuts. Turn around and do my y-intercept. So when x is going to be equal to 0, that is going to be my y-intercept. So we're going to have 2 times 0 plus 4y is less than or equal to 12. 4y is less than or equal to 12. Divide both sides by 4. And then y is going to be less than or equal to 3. And that is cashews. Cashews are going to be less than or equal to 3 pounds. So we would have cashews, 3 pounds max. Now, if I were to graph between those 2 points, and of course it's less than 12, so my shaded area is actually going to fall over here in that region, because we're going to be less than, so we're going to be below the line. And then any combination that fits within this shaded region is a solution. So there you have it. How would you graph that? There it is. Now, what would be 3 possible solutions? Well, 3 possible combinations would be any of these points. This, for example, if I were to have purchased 2 pounds of peanuts and 1 pound of cashews, that would have been a solution. I would have had money left over, but I did not exceed what I was allowed to spend. So there you go. There's looking at graphing this real world scenario. And then last but not least, that is not the correct question, just so you know. What we're trying to do here is we are trying to write an inequality based on this graph. And in doing so, well, if we're going to write a question in slope-intercept form, well, we need the slope and the y-intercept. But we're going to do the inequality. So let's just think, looking at this line, I have a y-intercept there, and my y-intercept is going to be 0. My y-intercept is going to be 1, which is 0, 1 of an ordered pair. And then my slope. Well, if I come over here and look at this line, I start here, I go right 1, and I go up 2. Let's go pick this point right here, and I went right 1, up 2. So it looks like my slope is going to be up 2 over 1, or it could also be down 2, back 1, depending on where you're starting. And looking at it, I have a solid or a dashed line. It looks like it's a solid line. And it looks to be that I am shaded in this region right over here. That's not a good... This region right over here is where I'm shaded. So in this shading, then, I am going to be less than, because the y values are less than as you go this direction from my intercept. So it looks like y is going to be equal to 2x, I just said equal to, we're going to correct that, but 2x plus 1 for my y-intercept. And I made a mistake and I said equal to, but it's not equal to. We said that it is going to be equal to that we have a less than or equal to sign. So there we have it. Y is less than or equal to 2x plus 1. And that took a little bit, but again, we're getting into areas that are new.